back to casting again. A long time ago, I showed you how to cast with the round brackets. So you have a floating point number and you write round bracket int round bracket and then the floating point number, and then that casts it to an integer. Maybe throws away the part of the number that was after the decimal point. You don't get a warning because, hey, you told the compiler you knew what you were doing. You can use round cast to go back and forth between different kinds of pointers, different kinds of references, but it's kind of a dangerous thing to do. There's nothing to check to see that it's okay what you're doing. And when someone else reads over your code, they may not understand what you're doing or why you're doing it. Very often people end up putting comments like, this is okay because I know it actually has a tweeter in it. There are better casts available to you, and now that you understand template syntax, you can use them. Here is the static cast. It's a template. It's an operator called static cast, angle bracket, whatever you want to cast to, and it's done at compile time. If at compile time the compiler doesn't see a relationship between what something's really pointing to and what you're trying to cast it to, or in the case of numbers, the kind of number it really holds and the kind of number you're trying to cast it to, you will get a warning, or in some cases an error, that they're incompatible. But if it could sometimes hold this kind of information and could sometimes hold that kind of information, you can be tripped up by a static cast because there are no runtime checks to help you out. The dynamic cast has a runtime check. And the runtime check relies on knowing what the type is at runtime. It's restricted to working with pointers to objects of classes that have virtual tables. The cool thing about a dynamic cast is that when you're trying to cast to a pointer, if it doesn't work, because at runtime it can be established that that's not really pointing to a tweeter, you get back a null pointer. And you can test against a null pointer. If you're trying to cast to a reference, it'll throw an exception. That's okay too. They're slower to use the dynamic cast, but it's safer. You won't ever misinterpret bits and cause really weird bugs of the kind that you can get when you misuse a static cast. Now, for the sake of completeness, I'll also mention Const Cast. I'm not showing you the exact syntax here. This is where you can actually take a const variable and cast it to a not const variable so you can change it. As you can imagine, not a beginner technique. Sometimes people will do this to handle caches and things like that where you're not really changing the object. There are other ways to do it. Anyway, not for beginners. Reinterpret cast is totally not for beginners. This is a matter of bit twiddling. This involves knowing how long certain data types are and the pattern of bits inside the data type, and you say, oh yeah, I think of that as being an integer, and then you put some values in it, and you say, now I'm going to think of it as being something completely different, and ask about its value, and the bits will be interpreted differently, the meaning will be interpreted differently. There is old code that uses reinterpret cast, but what I really use it as is a huge red flag to say, wait a minute, someone's trying to be really smart here. Is that actually necessary? And that's one of the ways that casts can really express your intent. A static cast is nice and safe between two related types, and you're really confident that this person pointer actually points to a tweeter, so you just feel like casting it to a tweeter so you can call some tweeter function. Yay. Dynamic cast, a little less safe, a little bit of a runtime performance hit, but you will be checked on and you will be protected. Const cast, very dangerous, and reinterpret cast, extraordinarily dangerous. This is the shooting your own foot off territory of C++, which is why I'm not going to teach you how to do it. I want you to know that it's there. If you see these casts in someone else's code, tread carefully. Let's do some casting back and forth between base and derived and see where that gets us to. Here's some code, again using person and tweeter, and I'll just show you that in person, the getName function is virtual. So that here, when you see calls in main to getName, you know that we're expecting to get the tweeter version if the pointer really points to a tweeter object, and the person version when the pointer really points to person object, regardless of the type of the pointer. So you can see what's happening here. I'm going to create a tweeter on the stack, make a person pointer by taking its address, and then I'm trying to take a tweeter pointer by just using the person pointer. And I have wigglies here. A value of type person star cannot be used to initialize an entity of type tweeter star. And in fact, if I build this code, I'm going to get an actually pretty insightful error message which says cast from base to derived requires dynamic cast or static cast. I'm trying to go from the base person to the derived tweeter. Now we can see that's true because we know that person's pointing to T, which is really a tweeter, so we know this is safe. But the compiler is not so sure. Now, one way around this, I can use the round bracket cast. Red wigglies go away, and this code will run. And I get the tweeter version with the Twitter handle. So like, woo, I win. I used round bracket casting and I lived. It doesn't really explain our intent, and it can really hurt you. Let me show you how this can really hurt you. I'm going to declare an integer. And then I'm going to declare a tweeter pointer to I, is equal to, hey, cast this to a tweeter pointer, would ya? The address of I. Compiler's like, well, I guess you know what you're doing. You said round bracket cast, which means get off my case. I know what I want. So let's just copy this line. Only instead of PT, we'll use PI, our freshly minted tweeter pointer that's pointing to a supposedly tweeter. I guess you know this is not going to end well. Boom. And of course it goes boom, right? I mean, I is not a tweeter. It doesn't have an implementation of getName. It doesn't have a first name, a last name, a Twitter handle, anything. There's no way this could possibly work. But I said that I knew what I was doing. That's why we say sometimes that if C++ had a motto, it would be, well, you're the programmer, or when we're feeling really kind of darker humor, it's your foot. You're sure you want me to pull this trigger? Okay. It's not my foot, it's your foot. And as the programmer, I don't want to shoot my foot off, even though the compiler will let me. So why use round brackets, which don't check anything? Let's instead use a static cast. So up here, the good one, I say static underscore cast, angle brackets, I want to cast it to a tweeter pointer, and then I put round brackets around the thing I want to cast. My angle brackets the wrong direction. There you go. Static cast to a tweeter pointer, P. Let's try that down here. Static cast to a tweeter pointer, address of I. No red wigglies here. Red wigglies here. Invalid type conversion. Let's try to build. Types pointed to are unrelated. Yes, that's exactly the problem. So this was a really stupid piece of code to write, and you know what? Using static cast saved me from myself and told me, wow, that was stupid. Why did you want to do that? So static cast will save me from myself. Sometimes what people would like to do is try a dynamic cast instead. Now, the dynamic cast won't object at compile time. What it'll do is if it can't make the conversion, it will give you back a null pointer, which you can test. You notice I'm getting wiggles here. That's because you can't use a dynamic cast with a fundamental type like int, or even with certain kinds of classes. The class has to have a virtual function. So I have good old resource in here. This is a handy class to keep kicking around, and it has a virtual function. So I can try to cast a resource to a tweeter, which would still be pretty catastrophic. So I'll create myself a local resource, passing local into the constructor. And so I'll still try to dynamically cast to a tweeter, but I'll use the address of this resource F instead of my integer. Let's try running. First I'll build it. Compiles without complaint. So when I tried to do static cast between totally unrelated types, I got an error message. Tried to do dynamic cast, I'm like, ha, I got away with something, eh? So let's run it. And it turns out I didn't really get away with it. And you know, this is why I say that the compiler is your friend. I would rather get my error messages as red wigglies right while I'm typing code, or at least as compiler error messages when I try to build, than after I run. Especially for a real app that takes a long time to run. These console apps just spin right up, but you have some big complicated GUI, you had to click 6 buttons to do a test case, choose things from drop-downs, wait while database connections go through, and then it goes boom. I would much rather get my problem pointed out to me, handed to me by the compiler. That said, I can prevent it from blowing up at all, because I told you when a dynamic cast fails, you get back a null pointer. So I can take the bad behavior and say if PI, in other words, if it's a true value, then I will try to call its get name. I successfully converted it to a tweeter. Great, I'll call a tweeter code on it. Else, I'll say something else like resource can't be cast to tweeter. Let's run that. Not surprisingly, it says resource can't be cast to tweeter. But let's recap. When we used round bracket casting, when I used static casting, it was just as sweet and useful for the good, proper, appropriate casting. We all know here that P really is pointing to a tweeter, so this is an appropriate cast. Everything went swimmingly well. The static cast refused to let me cast between integers and tweeters or between resources and tweeters. Dynamic cast didn't give me a compile error and gave me a way to check at runtime to make sure that this was okay to do. So if someone's going to hand you a pointer or a reference and you're not sure whether or not it's maybe one of the derived types, you can try casting it using the dynamic cast. And if it works, great. It really is the derived class and you can go ahead and call methods on it. Doesn't work? No harm done, just don't do the work. Now, when it comes to pointers, you really kind of know the rest of the story, the polymorphism story. This lets you write really general code. I will be given a collection of bank account pointers. They might be smart pointers, doesn't matter, right? And I will update them all, or if they're orders, I'll ship them, or for employees, I'll pay them, whatever. These sorts of constructs are all over your code. And they'll call methods through the pointer, very general methods that are defined in the base class like update or ship or pay. But the implementations that run will be the specific methods for updating a checking account or updating a savings account. for shipping a rush order or shipping a regular order, for paying a part-time employee or paying a full-time employee. They'll have very different implementations, but thanks to polymorphism, your calling code stays really nice and general. Yeah, take that bank account pointer and call its update method. With raw pointers, you get polymorphism. With smart pointers, you get polymorphism. With references, you get polymorphism. You don't try to decide which of those to use based on whether or not you're going to get polymorphism, because you're going to get it. When you're not using pointers or references or smart pointers, when you're using solid objects and copying them around, either the way we did in the demos with equal signs, or more realistically by calling some function that takes its parameters by value, when you take a derived object and copy it onto a base object, you get slicing. You lose the member variables that are unique to the derived class. That's almost never a good thing. When you use a pointer, you lose nothing. You still get polymorphic behavior on that pointer, and if you cast it back to the derived class later, you can then continue to call derived class functions using the pointer. You can do a lot of casting with the round bracket C-style cast, but I don't recommend it. I recommend for safety and for expressiveness that you use the cast templates, especially static cast and dynamic cast. Stay away from Const Cast and reinterpret cast, at least for now. In order to understand this topic, pointers, polymorphism, and inheritance, we had to cover the full gamut from your fundamental types like int and float and casting amongst them, designing and defining and declaring objects and writing functions of objects, all of the operators and arithmetic that make up flow of control statements to make a C++ application, and then tackle templates and pointers and the combination pointers and inheritance to get polymorphism, as well as the benefit you see from smart pointers and these cast operators, both of which rely on templates to work. This topic is sort of the pinnacle of what parts of C++ do you still need to understand. If you really followed all of this, then you understand casting, you understand pointers, you understand inheritance, you understand templates, you understand C++. So congratulations. Now you're ready to do some very, very cool things.